Welcome to the Introduction to Rational Functions video. In this video, I will explain what a rational function is, how you've already been working with them, what you already know that will help you with rational functions, the new things you need to learn, and show a few examples. What I will not be doing in this video is working any examples. I have several other videos that will demonstrate all the details you need to be able to answer all the questions you will be asked about rational functions. What is a rational function? It is the ratio of two polynomial functions. In other words, it is one polynomial function divided by another polynomial function. You have interacted with rational functions when you learned about the domain of functions and later when you explored long division. The last two bullet points show an example of a rational function and an example of something that is not a rational function. Some of the things you will explore about rational functions that you already know about are the domain, the x-intercepts, and the y-intercept. Some of the things you know about that will help in answering additional questions include factoring, simplifying, evaluating a function, the degree and leading coefficient of polynomial functions, long division, end behavior, and solving rational equations. Let's discuss some of the new things you will need to learn. Previously, when you learned about the domain of the function, the values that are not included in the domain may have been referred to as gaps, breaks, or even discontinuities. When discussing the domain of a rational function, we will distinguish these by calling them one of two things: point discontinuity or vertical asymptote. A point discontinuity is what it sounds like, a break in the domain at a single point. Oftentimes this is referred to as a hole in the domain or a hole on the graph. I will continue to refer to point discontinuities as holes in the future. Holes and vertical asymptotes will account for all the breaks in the domain. The breaks in the domain will either be a hole or a vertical asymptote, but not both. I will go into more detail about how to find these in a different video. Let's look at examples before we continue with more new things. This graph shows a rational function with a single hole located at the point 1, 2. The open dot on the graph is how a hole is indicated. This graph shows a rational function with both a vertical asymptote and a hole. The vertical asymptote is indicated by the dashed line on the graph. Algebraically, it is given by the equation x equals -2. The hole is located at the point 2, 0.25, and again it is indicated with the open dot on the graph. Three more new things to learn about rational functions are the horizontal asymptote, slant asymptote, and the end behavior model. Each of these is determined by comparing the degree and leading coefficient of the polynomial in the numerator and denominator of the rational function. You will also use long division to help determine the slant asymptote. You will have either a horizontal asymptote or a slant asymptote, not both. Whichever is present will determine what the end behavior model will be. You will also learn how to find if and where the graph crosses the horizontal or slant asymptote. I will go into more detail about how to find these in a different video. Let's look at some examples. This graph shows a rational function with two vertical asymptotes and a horizontal asymptote. The vertical asymptotes is indicated by the dashed lines on the graph. Algebraically, they are given by the equations x equals -2 and x equals 2. The horizontal asymptote is also indicated with a dashed line on the graph. Algebraically, it is given by the equation y equals 2. The end behavior model will also be the equation y equals 2. This graph shows a rational function with one vertical asymptote and a slant asymptote. The vertical asymptote is indicated by the dashed line on the graph. Algebraically, it is given by the equation x equals -1. The slant asymptote is also indicated with a dashed line on the graph. Algebraically, it is given by the equation y equals x. The end behavior model will also be y equals x. Thanks for watching. Continue with the other videos in the playlist to explore the mathematics behind finding everything you want to know about rational functions.